So we're being asked to compare the tensions between two pieces of rope, one attaching a larger mass B to a smaller mass A, to the string on the right, which is has some tension T1, which is accelerating the whole system to the right. So we're going to assume there is no friction. If you look at the free body diagram over here, the mass B, again concentrating on horizontal forces only, ignoring the vertical forces. There's only one force acting on B, and that is the tension of A on B, which is, assuming a massless string approximation, is going to be a Newton number 3 pair with the tension of B on A. So these two forces are equal and opposite to each other. B pulls A to the right just as hard as A pulls B. B pulls A to the left just as hard as A pulls B to the right. Mass A then has two forces acting on it. The tension T1 to the right and T of B on A to the left. Now we know the system is A and B are both have an acceleration to the right. And so if we look at A, there must be a net force on A to the right, which means T1 has to be bigger than T of B on A. We know that T of B on A is equal to T2 by the Newton number 3 pair. And so the argument then is, if you look at my cursor, T1 is bigger than T of B on A, but T of B on A is equal to T2, and therefore T1 is bigger than T2. The tension in string 2 is smaller than the tension in string 1. It's this last series of charts show how elegantly you can argue with a combination of Newton number 2 and Newton number 3.